All right. Meeting is being recorded. And share my screen. All right. So how's it going this morning?
Doing well over here. I'm going to mute myself with my dog in the background, but I'm listening. And if I have any questions, I will raise them.
You see my screen okay?
I do.
Perfect, cool. Well, today we're going to show you some of the things that we had a little bit of trouble showing last time due to a few technical difficulties. Wanted to really talk about MantisEdu and some of our IoT sensors, and more importantly, a lot of the software platforms that we have to kind of connect with things. So on my screen in front of you, you see MantisCode, which is our software IDE that allows you to connect with our sensors using things like Scratch and MakeCode. And we also, the sensors also connect via mobile devices as well. So to kind of do a quick refresher before I go to MantisCode, actually, let's start with our mobile apps. So I'm actually sharing my screen in front of you, and I'm going to walk through some of our sensors just to kind of show the examples first on mobile, and then we'll show how they work within the MantisCode environment. So remember, we have a number of sensors. The guy in front of me here is my climate tag. You see this? So this guy here is our multifunction data logger. You can plug in sensors into it, and this guy can measure things like temperature, pH, conductivity, turbidity, all wirelessly. So in this case, notice that on my phone, I'm actually paired with this sensor, and you notice the sensor value is actually rising. So if I were to hold this sensor, you see the value going up. So wirelessly connecting temperature in real time. And what's nice about the Mantis mobile app is that if I were to go through and actually tap on the sensor, I get real-time graphs and charts. But more importantly, I can actually share my data. So if I wanted to get data for this file, I can email myself the file by simply typing my email address in, or I can simply save it. But just to show you, I can save it to my device, and up top is the file name. That will be a running data log of all the files, the data that exists inside of that. So that's one example. Now, notice that while that's working, I'm also connected to this device, and this guy is called the MODI. The MODI is a gyro and accelerometer and distance sensor. So think about it as like a Fitbit on steroids. So notice how I'm going to sit it on his back right now, well, so you can in my hand. And notice that if I look at the Z acceleration, it's roughly negative 9.8, representing gravity, right? If I flip it over, you notice it's at, positive 10, 9, right?
Mm-hmm.
Now, watch this. You see the distance value around 100 right here?
Huh?
Now watch this. Let me put it back on. If I move toward my ceiling, what's happening? That's tracking distance in real time.
You are. I see it.
Right? So think about those kinematic experiments that you do typically where you're trying to, look at motion in planes if you're in physics, high school person. This lets you deal with both 2D and 3-dimensional motion all in real time. And what's nice about this particular sensor is that it comes with a rechargeable battery and it lasts forever. Okay, now let's look at another sensor. So in front of me here, this is what we call the soil moisture probe. So I'll turn this guy on, and when I go to this sensor, there's a limitation in iOS where you can only see the moisture values. But notice that I'm actually measuring in real time, and you see the sweat of my fingers actually detecting my moisture index.
Oh, wow.
If I remove my hand off of that, it goes back down, right? Data's coming in real time. And so here's the climate tag. This guy is nice because notice it's not showing now.
Mm-hmm.
If I click on this back, it comes on in fast mode. And in fast mode, what happens is that this sensor sends data every 5 seconds. So I click on it and notice that I'm getting in real time humidity, temperature, light, pressure, and my light is both ambient light and UV light. Okay?
Wow.
If you run the continuous experiment, you simply turn the sensor on the side. It only sends data once a minute, and this sensor will last for like months at a time. And using these little simple CR32 little cheap batteries, basically. You can buy an entire pack of these batteries for less than $8 on Amazon. But the sensor will probably run for 6-7 months off a battery that costs you less than $1. Okay. Now, and then one thing I forgot to mention. Let's go back to this guy for a second. Remember the sensor one. So I'll go back here and take the sensor one and let me unpair for a second, because this actually you can pair with this guy. but you're familiar with companies like Veneer and Pasco who sell a bunch of different probes.
Mm-hmm.
Probably seen like this guy before. This is like a Veneer dissolved oxygen probe, right?
Yes. Yes.
I can take a Veneer dissolved oxygen probe and plug it into the side of here, right? And then what happens is if I turn this sensor on and connect with it, I choose the probe I want to use. So we support Veneer conductivity, turbidity, dissolved oxygen, their light sensor, and their pH sensor. And so all these sensors can be leveraged with our platform and our mobile apps. Okay.
Okay.
So that's an example of the probes. And again, on our side, you notice as well, we also have temperature, pH, conductivity, turbidity. So all these sensors and probes, we produce and create those. So at a very high level, those are some of the sensors that we have. And you can see how they're using the traditional sense. So what I've shown you so far is probably not much different than what you've seen before, but it's a good way to kind of show how we can connect and get data from the sensor. Now, these apps that I'm showing you are on the App Store. They work on iOS and Android, and they're freely available. So it's not a burden to teachers.
Okay.
So now that we have that, like, how does that help you with computing? So most companies that create sensors or produce sensors in classrooms are simply focusing on what I just showed you, which is digital means, hey, I got this sensor value. Let me go and record it and get some data and go plot it. And that's the end of experimentation, which is a problem with computing. With computing, you need to be able to be a part of that, we call it data stream, and act on it and make decisions.
Mm-hmm.
And so what we've done is we've actually bundled a platform. We call it MantisCode. And within MantisCode, we have both Scratch, which is very popular in elementary and upper middle school in a lot of cases, actually in some cases high school, but it's one of the leading tools for visual and drop and drag programming for kids. And then outside of Scratch, we also introduced Microsoft MakeCode. Microsoft MakeCode, it hasn't been around as long as Scratch has been, but it picks up where Scratch kind of leaves off in that it starts with drop and drag programming, but it takes you to full languages like JavaScript, so you can actually control and actually look at true structural languages. One of the things that we've done, which I believe is unique, is that both of these platforms typically work only in online environments. And you'll notice in a second that they're all bundled in one location, and we can actually run code without having internet connectivity. Okay, so let's look at an example.
Wow.
So inside of MantisCode, I click on and I can browse and see every sensor we produce inside of here, right? So let's take an example. Take that same climate tag I just showed you. I click on the climate tag, and I can actually load different examples, right?
Mm-hmm.
So I'll open up this starter example. So remember, when I was on my device, this is my climate tag. And if I click on it, notice it has I don't know if you can see it or not, but it has a MAC address.
Yes.
Right? That's a unique identifier. So the last four are 4EFD. Okay. So I can take this little Scratch program and put the last four just for shorthand. And by literally clicking a button, it's going to go out, find a device, and get data in real time.
Wow.
Now, notice if you've ever used Scratch before with Lego or anything else, you typically have to go write code, download some firmware, attach a USB cable before you can get some data.
Cross
right?
fingers. Mm-hmm.
So in this case, this device is operating as a beacon, which means that, notice I didn't pair with it, right? Which means that if I were in a classroom and I had a one-to-one scenario and kids had Chromebooks or whatever it may be, devices, as a teacher, you can actually have an experiment, excite some phenomenon, and have all the kids work on the same data set wirelessly. But it was literally that simple,
Wow.
right? So that's one example. So what could you do with that? So if I were in here, I would do something like this, where I take this example and say, hey, you know what? Let's have some fun, kids. Show you what Scratch can do. So, hey, let's do a for loop, and let's do an operator. And in my example, I have all my Mantis variables living in a variable now. So if my light value is greater than, I'm going to put 37,000 for now. Maybe I have fun and say, you know what? There's a new thing in Scratch 3 where they have a text-to-speech bubble, right? So say it is bright, right? And you probably, sorry, somebody just joined the meeting. Let me find out how to let them in.
Okay.
How do I do this? Okay, so maybe now I want to do that, and I come over and say, Where was I?
Uh,
Control, right?
Mhm.
And I'm gonna make it wait. I'll have it wait for maybe 1 second, right? And just for the giggles, I will put it inside of maybe a forever loop, right? So it always checks. So now this program is running. It's checking for light, and my value. Click on my. Actually, make it louder. Yeah, I'm gonna put it at 40, and I'm gonna click on that loop. It's not saying anything. So how do I get light? Let me go to my cell phone and turn my light on. And the sensors reads data every 5 seconds or so. So in theory, if my code is working, at some point this value should update. Oh, my sensor went to sleep because it's been around for a while. Yeah. Wake back up, sensor. We're in a live demo. Don't do this to me. Okay. While we're doing this, is somebody else just joined, I believe? Okay.
I don't see anyone.
There we go. You heard that? Did you
No.
hear it? Yeah.
I heard.
I don't think I shared my audio. Let me turn my volume all the way up.
Okay.
I forgot to share my audio when I shared my screen, but it said it is bright, right? But so again, I was able to, in real time, take a sensor, connect with it, and use it to do something. So how have we used it in the classroom? We've done examples. So when you look at things like Scratch, typically a lot of people use Scratch to have kids maybe build storyboards or narratives and things along those lines. So we've had kids go and they learn how to build sprites and how to change scenes. But we'll tell them that, hey, here's Internet of Things. This is a device. It collects data. You must use the data points from the device to tell a story in Scratch. And so these sensor values and things that you're doing have to help you navigate that story. So that's one example. Now, let's do this. And again, I can come in even with the same sensor and load a different example, the exact same sensor, while this one's still running in the background. I can come over, load a different example, and continue to work on it. So I can actually have multiple tabs running at the same time without having to stop my experiments, right? So in that case, this is the same thing. I'll change my MAC address again for EFD and run it. And this example does the same thing, but what it does is actually plots a graph. So I'm getting real-time graphs, in Scratch. Okay.
Math, science, hands-on.
Oh,
wow.
So now let's look at a different example. Let's go back to that Modi. This was the one we talked about, which was the one that actually. Oh, this is the one that does the motion, right? So let's go in here and open up a Modi example. So notice again, without getting terribly technical, notice it says localhost. So I'm actually running Scratch. If I had a school that had internet connectivity problems, once this software is installed, they can use this without being online at all. So now I go and connect. In this case, I tap the button to pair, like it said. It's going to go out, find this sensor, connect with it. It found it. And now I'm getting real-time data, motion movement. So imagine if I were in a robotics club and I wanted to build the next Wii controller. You could actually take this guy and use it as a motion controller for something or do things with it. But again, notice it connected and this connected while this guy is still running and this guy is still running, right? Temperature still being updated. Okay.
And it's locally hosted, meaning that you could do this without the internet.
Yep. So now here's an example of our 3D printed kit that goes, we 3D printed an open source designs for a robot. Okay. And we have a robotics control board. So in this case, I loaded an example where, very simple example, where I connect to a robot and I can move arrows. So up arrow, it sets the motor speed 100, forward, back, left, and right. So in this case, I connect to the robot and let's connect with it. Make sure my battery's plugged in. Actually, let me reset it real quick. So again, the entire idea is that you can connect and do things really easily without having to, go crazy and worry about technology, basically. So in this case, we have a 3D printed robot that we can create. That's one example. It just connected, right? So check this out. Up, down, right, left, stop.
Wow.
Now my other sense is still saying it is bright, right? This guy's still running, and I'm still doing motion experiments all
Right.
the time, right? So so that's happening. Now, again, same idea. It keeps saying it is. You guys can't hear, but it keeps saying it is bright to me. And this is another example of the same robot, just for giggles. Another example, same code. So if you were a CTA department and you wanted to go teach your kids how to design and build, they could go and make things like this, right? And then you go and control. So that's a robotics controller. So you may use that to go and let me see. You may make a windmill or something. It moves things back and forth. So that's an example there. Okay. Now let's look at something else. I showed robotics. What else can we do? Motion robotics. Let's go back. Oh, now, so let's go back to, so that's a lot of stuff in Scratch. So same thing with the sensor one. I could go to the sensor one, right? I can load the sensor one. And in this case, let me disconnect from the other machine. The sensor one project, if I wanted to go build like an aquaponics or a hydroponics something, right? Because I want to use multiple sensors. I take the sensor one, and in this case, I will take it and plug in, like before, the temperature probe. And I hit connect, right? It's starting up. It tells me to tap the button. So it goes out, it finds it, right? And now that it's found it, it's initializing it. And it tells me which sensor you want to use. I want to use a temperature probe. So I literally click on that temperature probe. It goes out, it sets the sensor up into that particular mode. And now inside of Scratch, look at the bottom right. So now I got wireless temperature coming in real time in Scratch. So again, cross-platform, working everywhere. So that's Scratch. So let's stop. So now let's go and look at some similar ideas. So now let's look at, I'll close those out just to get out of the way. And let's go back over here. And we also, just to show you, we also could do the moisture. So same idea. Everything we make works everywhere. And we also have what's called Scratch Playground. So let's say that you didn't want to do anything with the sensors. You just wanted to go and teach Scratch additionally or find additional lessons. You can go to the Scratch Playground. And since this is all based on just the regular version of Scratch, you can do whatever you want to. So this is just regular Scratch, and you can do everything at low projects. So it's not limited to just our stuff. We just integrate onto Scratch. Okay. Now, let's go out and look at what else you can do. So Scratch literally stops with drop and drag, right? MakeCode starts with drop and drag and can go farther. So again, notice local host. I have MakeCode, same sensors live inside of here, but I'm going to load up this example called Demo Works because you always want to get a demo that works, right?
Always.
And this is cool because are you familiar with Weather Underground?
Yes, I learned about it when I looked it up after you told me about it last week in your presentation.
All right, cool. So Weather Underground is a real-time weather dashboard. So I'm going to go here and open up this personal dashboard that we use. This is actually one of the examples we built in a little test dashboard. So, and let's talk about MakeCode. So now this looks familiar to you, right? Very similar code, right? Almost like our Scratch code.
See the probe,
And we set values, so almost similar. So imagine now you're a kid, like you walk over here, it's the same example. Nobody's really making you learn anything too much different. But the cool thing is this, Notice we have this thing called push to cloud now on the bottom down here, right? So it's a function here that says push to cloud that's doing some magic and it's taking inputs. And that function is actually down here that's doing some work. And what it's doing is actually building the JSON string, right?
Wow.
And if I go to JavaScript now and I'm learning some stuff, this kid comes over here and is like, what does that mean? Here's a forever loop, push to cloud. Push to cloud is actually building a JSON string and it's making an HTTP request, right? So it can make those things happen. But for the simplicity of it, just like with Scratch, you just come over here and open this thing up. And when you open the page up, you just run the program. And when you run the program, it builds a JSON string. See, it says 7 seconds ago. It's pushing JSON data to the cloud. And it's giving real-time updates. Their website's a little slow today for some reason, but this is early. You see my temperature, humidity, and pressure coming over. All those values are data that are being pushed from Scratch. So in real time, check it out. The temperature value that I have has been pushed to the cloud.
When I taught earth science, this would have been so useful.
Yeah. So now you have a person coming in saying, why is coding important? So if I come back over to this MakeCode example, I'm like, hey, you know what? Here's a loop. Here's data transformation. Here's cloud. Over here, notice we're showing the JSON string and we're showing the success value. That's a function. That's a loop. And things like that. And so this example, MakeCode doesn't, MakeCode doesn't have all the bells and whistles of Scratch when it comes down to like all the sprites and things in terms of how we implement this interface. But this really was meant to get into true languages. And so one of the things that we're doing next is that we're going to allow for kids to be able to build code, understand it. We're building examples to go and talk about the JavaScript side of the equation, because the cool thing is that you can actually code in both sides. So when a kid actually wants to write JavaScript, as an example, they can code in this view. It'll add blocks in the other view. And this is true functional code. And so we're building examples now where if you were like maybe an upper middle school or a high school kid, that we'll be able to take these examples and actually run them offline in a real environment, apps in the web environment. And that's where the true magic will happen. So now I can go build a web app or a mobile app or something that's doing real world examples. And the cool thing is that I'm leveraging these same sensors in ways that I hadn't done before. And so ultimately, our goal is to make sure that, we can get from, a full life cycle. So I have a kid in elementary learning Scratch. They go to middle school, they have Scratch, we move them to MakeCode, right? And then when they get from middle school to high school, they go from MakeCode to functional languages. So now they're using Java and Python and these real languages. But the beauty of it is that these sensors that we have, they follow the kid throughout the entire life cycle to make that happen. So I'll show a couple more things that I think would be interesting, just to show some examples. So let's go back over to that robot example, and I'll show pieces of this video to give an example. So robotics is a use case that's very popular in schools, and it usually comes down to what I just showed you. Turn the robot on, it blinks, and it rolls. And although what I just showed you was interesting because of the connectivity back to Scratch, it still is actually not terribly, it doesn't take you far in terms of a unit or teaching, right? So I like to look at things as it relates to real world skills, right? So a prevailing topic narrative right now that's really important for skills in the industry are autonomous vehicles. It's a huge topic. So in this video, you see all the 3D printed parts. So the CTAE person is happy, right? And you're building this robot with all these pieces. And let's see what it does. We construct a robot. So this one actually takes and puts a LiDAR sensor on it. And now our distance sensor is controlling and making a real-time obstacle avoidance using Scratch. Right? So now you're telling the kid, you're making a robot, you're making the next Tesla, you're making the next BMW, and your responsibility is coding to make it an autonomous vehicle. And that's a much different use case and now Scratch is your control system. So instead of having to write firmware, flash it every time, you can do this all in real time and you change your code and it literally is happening as you do it, right? Another example we spoke about was aquaponics. So I showed you guys some examples of things we were doing with aquaponics. Like this is our DIY aquaponic system. This is in my sunroom now, and it's growing tomato and things along those lines. So you notice on the left side, it has the sensors, because when you're growing, what do you care about? Light, temperature, pressure, humidity. You care about pH, conductivity, temperature, ammonia. And then you have pumps and valves where you got to actually be able to, regulate the system. So in aquaponics, there's a method called ebb and flow. And that's where you cycle your water, you hold it for a while to let the roots absorb the nutrients, and then you drain it, right? And inside of this system, what's happening is that the fish are urinating, they're creating ammonia, and that ammonia goes through this biological cycle where the bacteria and the ammonia kind of do some magic, and they create these nitrites, and then they create these nitrates, which the plants love. And you just keep cycling the system, filtering it, going through. And so how do you control that, and have a kid understand this is actually a computing system, a closed loop system. So here's an example of a video where we're highlighting that controller, where this controller is the Untitled controller. So we took an earlier version. Oh, so you'll love this. We took Raspberry Pi and ran this on the Pi. So here's a video showing that system using soil marsh. So the system is watching the water level using the soil moisture probe. When it gets to a certain level, it turns the pump on, and the control system for that is scratch.
See, I told you I could actually not kill plants with this. See, okay.
Yeah. So the ball valve is being drained by using scratch. So that same controller that's driving this is actually on the system I just showed you. So if you notice on the bottom right, so scratch, the controller actually controls the pump that pumps the water in. Mm-hmm. And it also it can control up to 6 outputs. So it also controls that valve to open and close that valve. So it becomes a control system. So all that happens. So now imagine where everything I just showed you there was being done on a computer, right? Mm-hmm. So the cool thing is that we also have a version of our Scratch program, like MantisCode, which is what we call it. It also runs on this guy. So I can take the Pi and have it become my control system using Scratch or MakeCode on a Pi. I can use it on a Chromebook. I can use it on a Mac. I can use it on a PC. And this stuff just works effortlessly across various platforms. So, wow. So I'll pause there for questions. I know I've been talking a lot and I talk fast most times, so I'll kind of and see if there are any questions. But yeah, but that's the game plan. So everything I show you works everywhere across platform, and we're in the phase now to where the tools are working, the technology is working. Our team is building out curriculum around using these in classrooms. Mm-hmm. A couple examples, we're doing some camps this summer with Rice University, where they are doing camps where they're rising for high school kids. Mm-hmm. So as an example, we're doing a course with Rice that is focused on Python programming, where every kid is then sent out a climate sensor. They're learning Python, but within the context of machine learning. So they're actually building machine learning models to do to build an algorithm that can detect anomalies using real-time IoT data. Using that. So now our focus is how do you take these educational standards that are out there, build real-world examples to make it happen, and then package all of this stuff inside of an environment that's turnkey so that teachers can use it without going crazy. And I actually said I was going to stop. There's one more thing that I haven't shown. We also, when you get beyond the things that we're describing and you get into the high school side of the equation, we also have the ability, we integrate with a full-blown learning management system. Think of Blackboard meets computer science. So we have a web-based environment where we can actually embed inside of that environment examples, computer science, like every language that you can imagine, C++, Python. And within there, we also can connect in our sensors. And that platform allows auto grading, plagiarism detection, and all these pieces. And it just manages the entire infrastructure for you. So we believe we have access to the entire life cycle that's needed to support everything from CTAE to STEM to computer science scenarios, but doing it in an integrated kind of cross-discipline industry-focused way that excites kids and allows teachers to participate in it without having to always be the domain expert. So I'll pause with that.
Wow. So just for audience sake, what are the costs? If you could give some costs on some.
Yeah. So the cool thing is, yeah, everything we built, we say that we've made things that are best in breed but affordable by design. So these environmental sensors, like I said, they individual costs. This is some. If you were just buying one of these guys, I think it's somewhere in the $85 range.
Okay.
The climate, the moisture probe, I believe retails about $75 MSRP. The MODI sensors is about 125. The sensor one is similar, and the different probes have values around that. We typically only, since there are a lot of vendors that focus on the probing space, we don't really often sell the sensor one as a individual sensor. It typically comes bundled with like the aquaponics and all those pieces because you're using it for a use case.
Right.
The aquaponic system that I showed here, we actually built this to be a classroom level system that comes kitted up with everything you need to kind of drive it and control it. And so that full classroom system, I believe, is somewhere like the $2,300 range, but it comes with all the sensors, all the everything. It comes literally ready to assemble, as you see, with doing that. And one thing we pride ourselves on is that, in the Robotics Kit, we built that to be a robot that was something that would be something that was sub 150, like sub $200, so 150-ish range. And we open source all the 3D models and everything that go along with that. Our software, we don't charge for the software. So the apps in the App Store, they're free. The MantisCode is free. All the examples I've shown you today are free. And we are working on scenarios where we can actually build curriculum packs and things to kind of go along with that. That may be like an add-on price, but you can get out of the box and everything I've shown you today, if you had one of these sensors, everything I showed you today is just kind of there. And we think that's an immense value given how people typically are pricing things in this market.
Definitely. I mean, even the 2,300 is not undoable in a school system.
Yeah, because in that particular case, most schools are buying these really elaborate, expensive scenarios that they can't maintain. This one is nice because, again, it's a manipulative that sits in a classroom that also backs itself as a computer science operation, right? So it's literally a robotic system or whatever. And I think that the fact that you use it, you're not just buying a tower garden to watch a plant grow and say it grew.
Right.
It's a part of daily instruction or the after school program or the summer camp. And I think that gives you a lot more utility and a lot more value. What we found, frankly, is a few of our customers have not only bought this system, because remember that system uses each of these sensors as a part of it as well. And so they will buy that sensor and maybe a classroom pack of a few of these sensors, and then build in lessons that help the kids get exposed to the sensors as, background knowledge. And then that becomes the ultimate use case. And so you find a grant, you go find maybe, $3,000 to $5,000, and you'll end up having, one of these systems and 15 to 20 of these guys, and you have enough to go work with to really, do a lot of cool things with doing that. And so that's a use case that we found that seems to be a nice sweet spot that principals and teachers can make the investment. And I feel like they've actually taken their entire supply budget and only thrown it toward, one unit.
Right. One unit, one time use, and then that's it. But this right here, this is daily,
Daily, like after you do something like this and you take it to an after school or extended day type scenario, you get a lot of life out of it. So you can run an entire summer camp off of this one thing, and get a lot of utility from. And we've done that in the past as well, and it seems to be pretty interesting. And again, it's very tuned into, particularly in Georgia, it's very tuned into local industry, the things that we're doing here, and some of the major corporate partners that we have are embracing these technologies as well.
Right. The middle school where I was, the aquaponic system was not that compact. And this right here, you could technically move this from space to space. But
and the last thing as well, if you already have a system, then you just buy the sensor pack and you instrument your existing system, and that allows you to get data from it. So you can just go take this guy, put some sticky tape on the back of it. Like I have these little Velcro packs here that I'm working on because we're about to go light a greenhouse up. I take this Velcro pack, put it on here, stick this on the side, and now my system that I already have has data. And so if you truly know what you're doing, you just bring the sensors to it. So this is a design, but we have a high school in the fall that's going to go design their own system, and they're just going to use our sensors to make it smart.
Multiple uses. I mean, wow. I was impressed just with the talk, but the pictures and the
Yeah, that's why I was really mad before, because imagine trying to explain all this stuff and you need a visual. So this is definitely a much better format. So I'm glad we were able to reconnect and show you guys that I just wasn't making it up. It actually does exist and it does. I pride myself on trying to do live demos. Is got me a couple of times, but I like to show. I don't like coming in showing PowerPoint. I like to show it working. So.
Well, this was awesome. We really, really appreciate it. And I'm sure that once people see this, you're going to be getting many more phone calls, many more emails.
Cool. Well, thank you. Like I said, everything we have, we're going to start putting more content out. But anybody who wants to find us, just go to MantisEdu.io, MantisEdu.io. And there's some blogs out there showing a lot of things, how we used it in the past. For smaller orders, you can actually purchase the individual sensors, some of the sensors there. Let's connect and do something big together. And I'm excited about this, and I think that like I said on the talk, we're looking for partners, particularly local partners that we can connect with and really push this stuff out.
Sounds like a plan. Thank you so much.
No problem. Well, thank you for your time, and we'll be in touch. Okay.
All right.
All right. Thank you.
Bye-bye.